Ladies and gentlemen, it is me, Miss Gordon. I'm here with you today to talk about what is the purpose of our STEM lab. Now, we have started looking at photosynthesis and we've looked at that photosynthetic reaction and this idea that we need sunlight, carbon dioxide, and water in order to create a chemical reaction that produces sugar, which is the food for all living things. And what we're going to talk about today is how do we connect this idea of photosynthesis and give it purpose to a real life scenario. Now, our focus is going to be Mars. Now, what you may know is that there are many research teams that have formed and are developed in order to study the likelihood and the possibility of humans living on Mars. So, we're going to start with just a quick introduction that goes over how is this possible and what are the considerations.
Could we live on Mars? What happens when the human population outpaces the resources of our planet? Many people wonder if moving humankind to another planet is possible. Scientists agree that of all the other planets in the solar system, Mars would be the most habitable. But that's not saying much. If the goal is to create a self-sustaining Martian world, life will be difficult and dangerous. Mars has some similarities to Earth. Its axial tilt is about the same, so Mars experiences similar seasons. However, its orbital eccentricity is much larger, so the length of the seasons varies, and a year lasts almost twice as long as on Earth. The length of a day is about the same. The desert terrain is similar to some regions on Earth. However, despite these similarities, Mars is a completely hostile environment. There is no breathable air and very little air pressure. Lower gravity presents problems for prolonged settlement. Temperatures vary widely. While they may climb as high as 70 degrees Fahrenheit, in some places they drop as low as minus 225 degrees. The soil is toxic, and radiation from the sun is deadly. All this may seem a little too out of this world, but some scientists and a few entrepreneurs hope to make the dream of life on Mars a reality. Technology will be a major player in a successful Mars settlement. Residents will require constant pressurized and heated environments. Luckily, the planet provides a few raw materials, such as soil, to make concrete. Mars is home to several large caves, which would screen settlers from radiation. Residents may be able to grow plants after removing harsh chemicals from the toxic soil. Water on the fourth planet from the sun is available, but the atmosphere is too thin for liquid water to exist for long. Instead, water is trapped just under the surface of the polar regions. Extracting water would be vital for drinking, growing food, and producing oxygen. Space is opening up to the private sector, and a few companies are taking one small step toward life on Mars. Elon Musk, the founder of SpaceX, a space exploration and technology company, aims to build a colony of 80,000 people. SpaceX announced plans to put humans on Mars as early as 2026, 10 years ahead of NASA. But getting to Mars isn't as difficult as landing, surviving on the planet, or even returning to Earth. Musk told CNBC, "The thing that matters long term is to have a self-sustaining city on Mars to make life multiplanetary," indicating that Mars could be a refuge in case we outgrow our current planet. Given Earth's dwindling resources, that could be sooner than we think. Thank you so much for watching. This video is part of Thought Cafe Plus, a new collaborative animated series with people and organizations we love, like Popular Science.
All right, and I'm going to pause that right there just so that we can talk briefly about some of the things to consider as we look at our STEM lab. Now, let's consider the many challenges of moving to Mars. And I just want to point out that there are many. The access to water, the viability of the soil, these are things that are definitely going to be challenges for many scientific teams. Now, I want to point out that the focus of our lab is not to consider all of the variables that are going to provide challenges on Mars. Our focus is going to be food. How can we maximize self-sustaining food on Mars, specifically growing plants that we can eat? Now, scientists have already studied this. We have made on Earth a habitat called Biosphere 2, which is a huge dome. It's in Arizona, and it's designed as a self-contained ecosystem where researchers went and lived there for 2 full years to try to identify the problems or challenges of having a closed system as a precursor to being able to move something like this to Mars. The goal of Biosphere 2 was to create an ecosystem self-sustaining on Earth that we could then mimic on Mars. I'm going to show you a brief video about Biosphere 2 so you can see some of the things that happened during this 2-year research. While we're watching, consider what problems did Biosphere 2 have? Was it successful? Why or why not? And keeping in mind that our lens here is the viability of growing food, and consider what are we thinking about when we want to grow food on another planet.
There was a movie called Silent Running.
A space convoy on a strange voyage.
It was an Armageddon type scenario. The world had become uninhabitable and all the plants and animals were stored in these domes out in space. I just knew I was going to do something that was connected to that movie. I was totally taken.
And our ships to commercial service.
Biosphere 2 was so ahead of its time, it was very difficult to explain what we were doing. There were some drawings, and I carried a postcard around in my back pocket. So if I was at a party and someone asked me what I did, I would say, I'm helping build this. It's going to be completely closed to the outside atmosphere, and I'm going to live inside it for 2 years with 7 other people.
We must commit ourselves anew to a sustained program of manned exploration of the solar system, and yes, the permanent settlement of space.
As far as I'm concerned, it's man's destiny to go into space. The media expectations were really high, and it was to a large extent our fault, because we had promoted the idea that we were going to go in and it was going to work. For all intents and purposes, nothing material comes in and nothing material goes out. We would be able to create an atmosphere that people could live in for 2 years, to grow all of our own food for 2 years, and to do what we said we were going to do. We wanted to pack as many different organisms in there as we possibly could, with the full knowledge that not all of them would survive. It was such a wonderful group of people working towards a common goal, and a goal that I really had as well, which is to learn about the Earth. I don't think anything could have really prepared us for those 2 years inside Biosphere 2. I didn't have an illusion that we were entering utopia. Paradise in terms of the living systems, it was very beautiful. But I knew that there would be problems with us human beings. Imagine that you were shut inside with your immediate family members for 2 years, and you didn't get to see anybody else, and you just had to be with them night and day. There were some mean times. People did not talk to each other. It very much was a split of 2 groups. The main chasm between us was the different ideas of how we would manage the biosphere. Most of us were hungry most of the time. It was difficult to walk up a couple of steps without stopping to take a deep breath. So we put oxygen in. We said we were not going to do that, and we did that. So, in a sense, that was a failure. Very often people got the wrong end of the stick. They thought it was some kind of survivalist game, some kind of showpiece, some kind of, do or die enterprise. It was very hard to get across the idea that it was an experiment. There's no such thing as success or failure in a scientific experiment. If something doesn't work and we figure out why it didn't work, then it's not a failure.
All right. So again, that is a real story of a closed system that was created in Arizona to act as a precursor of what could happen if we tried to do this on Mars. And one of the questions that you see there on your screen is, what problems did Biosphere 2 have? And was it successful? Why or why not? Now, you probably heard in the video that they did have some issues with oxygen levels. They did have some issues with other management and personality things that happened within the research team. But again, our focus is going to be, what is it about Biosphere 2 that we can learn from and use on Mars? Now, remember, our focus in this lab is not all of the many variables to consider when we're thinking about moving to Mars. Our focus is growing food. How can we maximize photosynthesis within this biosphere so that we can grow enough food to support human life? Now, remember, Elon Musk is shooting for sending crews up to Mars in 2026 to begin this biosphere project. And his eventual goal through SpaceX is to get 80,000 people living on Mars. That's a lot of food. So what we want to consider is many variables of photosynthesis and how can we improve it or increase food yield by manipulating certain variables. Just as a review of photosynthesis, remember, photosynthesis is the process of creating food through a reaction that uses light as a catalyst to combine CO2 and water. If we look at the word photosynthesis in Latin, photo is the word part in Latin that means light, and synthesis means to make or produce. Now, don't be confused that photosynthesis does not create light or create energy. Remember, it creates sugar. Sugar is basically the money, right? The currency of photosynthesis, and it's what we're looking for when we're talking about increasing our yield. Now, in our experiment, we're not going to measure sugar. That's too hard for us to try to measure in this lab. Instead, in this lab, we're going to be measuring oxygen production, which of course, oxygen, as you remember from our learning about photosynthesis, it is a waste product of photosynthesis. It is released by leaves as the plant photosynthesizes. Now, that's all for this presentation today. I want to remind you that when we're thinking about our experiment and how we connect it to Mars, remember, our goal is that we are the chief botanists. We're part of the botany team to develop this biosphere on Mars. So we're not worrying about every variable to consider when it comes to moving to Mars. Our task is to analyze one variable that will increase photosynthesis in the Mars variable. And that's what's coming up next in your lab. You're going to see several different variables. You'll see light intensity, temperature, you'll see light color, and there may be others that you're going to look at and determine what are the best conditions for growing food. That's all for this, for this presentation. I'll see you guys next time.